In the last video, we broke down what's going on here. What we're doing is essentially just passing Keras' sequential model, an input, aka our image of a dog, and then MobileNet v2, aka this model URL that we're using, is going to find the patterns inside it. And then we're going, hey, no, we don't want the same shape as MobileNet v2. We'd rather convert it to the size of our own output shape, which is the amount of labels that we have, or the amount of unique labels that we have. So now let's talk about what's going on in compile. Oh, and by the way, if you do want to dive deeper on any of this, I encourage you to search it up and figure it out and try out yourself. We're going to see the outputs of this later on, so we're going to actually see the code running. But whenever you look up something and try to figure it out, even if you don't understand it the first time, trying to figure things out for yourself is a way to really cement your knowledge. So if anything here you want to look up and find more, don't be afraid to ask a question, and don't be afraid to look it up and check it out, what's going on behind the scenes for yourself. Now, what is happening with model.compile? This is something else you'll see when we're building a model with Keras. And so I think this one is best explained with a story. Let's say you're at the International Hill Descending Championships. That's right. You're one of the world's best at going down hills. And you start standing on the top of a hill. And now your goal is to get to the bottom of the hill. But the catch is that you're blindfolded. And luckily, your friend Adam is standing at the bottom of the hill shouting instructions at you on how to get down. And at the bottom of the hill, there's a judge evaluating how well you're doing. They know where you need to end up, so they compare how you're doing to where you're supposed to be. And their comparison is how you get scored, aka your accuracy at getting down the hill. You might be wondering, Daniel, why am I at the International Hill Descending Championships? Well, let me break it down. This is where the model.compile comes into play. Let's turn it into this terminology, because this can seem very confusing when you first begin. So the loss. So the loss is the height of the hill. Now, our model's goal is to minimize the loss, getting it to zero, aka getting to the bottom of the hill. So this means that the model is learning perfectly. Loss is a measure of when the model is learning, so when it's going through the training set and comparing the image to a label. The loss is a measure of how well the model is guessing. So when it's trying to make a prediction whilst it's learning, the higher the loss, the worse the prediction is. So the worse the model is learning patterns. The lower the loss, the better the model is learning patterns. Just like you, if you're descending the hill, the higher you are on the hill at the International Hill Descending Championships, the higher you are, the worse off you're doing. So your goal is to get to the bottom of the hill. And now if we come back, let's discuss what the optimizer is in our hill story. So your friend Adam at the bottom of the hill who's telling you how to get down the hill is the optimizer. He's the one telling you how to navigate the hill, aka lower the loss function, so how high you are on the hill, because he can see what's going on. He can see your movements. So he's basing his instructions on what you've done so far. And now his name is Adam, your friend's name is Adam, because the Adam optimizer, yes, it's actually called the Adam optimizer, is a great general optimizer which performs well on most models. So if we have a look at this, we go Adam optimizer. Adam, the latest trends in deep learning, gentle introduction for Adam optimization. And if we go machine learning model optimizers, it's going to tell us a few more types of optimization algorithms. So this is what's going on here. The loss function is how high you are on the hill. You're trying to minimize that because you're at the International Hill Descent Championships. The optimizer is your friend Adam at the bottom. You could also use another optimizer called RMS prop or stochastic gradient descent. But generally, to begin with, Adam is pretty good on most problems. So Adam's telling you how to get down the hill because remember, you're blindfolded. you're a model who's going through the training data for the first time and trying to learn patterns, or trying to go down the bottom of the hill for the first time blindfolded. And then finally, the metrics here, this is the onlooker at the bottom of the hill. This is the judge of how well your performance is at the bottom of the hill, telling you how you're going at the championship. So in our case, it's giving us the accuracy of how well our model is predicting the correct image label. Whew. So that's a fair bit to go through, but these are 3 parts of most deep learning models. Basically all of them. You're going to have some sort of loss function, so how well your model is guessing. You're going to have an optimizer function, so a function that helps your model improve its guesses. And then a metric, which is a way of evaluating those guesses after it's learned. So this is a step that we're going to have to take with when we're building any Keras deep learning model. We define the model as some sort of layers, and then we define how the model is going to learn. So hold on to that little story. If you have any questions about the story, or if you want to figure out what loss function you want to use, search up something like, what loss function should I use? How to choose loss functions when training deep learning models. Beautiful. This is a great resource, or it might be. I'll leave a resource there, how you can choose a loss function. But mostly it's going to depend on what problem you're dealing with. So if you're using binary classification, aka if you're predicting whether something is one thing or another, such as images of cats or dogs, you would want to change your activation function to sigmoid, and then your loss function to binary cross entropy. So we change this to binary cross entropy. But because we're doing multi-class, we keep it at categorical cross entropy. Because if we come here, multi-class classification, activation softmax, loss, categorical cross entropy. Now this is a lot to take on. So don't worry if you don't get it to begin with, but remember the hill story. Remember what the loss is. Remember what the optimizer is, just your friend Adam telling you how to walk down the hill. And the metrics, you could use a bunch of different metrics here. So if we go here, TF Keras metrics. This is going to tell you some metrics that you can use. Accuracy is the default one for classification. But we've got area under the curve, categorical accuracy, a whole bunch. Mean, precision, recall. So a whole bunch of different options. I'll be sure to link those as well. But that, we've gone through what compiling the model does. And then finally, we can finish off with this one, because building, I think you can imagine what's happening here is just another little way to say, hey, this is the input shape we're going to take to our model. So we're using a Keras layer from TensorFlow Hub. And if we come back to here, it says that if we want to use this layer, we set up a sequential model and then build the model with our input shape. And it's this shape because that is the size of images that MobileNet V2 was trained on. All right, now that has been enough talking. We've broken down what our create model function does. If you have any questions, be sure to leave it in the question and answer or in the Discord chat. But let's have a look at what's going on. We'll probably actually in the next video just quickly debrief what's going on in summary. But the next thing we want to do is create some callbacks for our model. So while our model is training, callbacks are going to be some functions that are going to implement a few little helpful things that our model can do while it's learning patterns in the data. So I'll see you in the next video.